All right, we're on Chapter 7, Section 4, which is Learning Plan 4.4. Equations with rational expressions and graphs. We're going to find the domain of the variable in a rational equation, solve rational equations, and then graph them. The first thing that you'll notice is that a rational equation has at least one rational expression with a variable in the denominator, and the domain is the intersection of the domains of each of the different rational expressions. So in this case, x does not equal 0. That comes from here. And then 4 does not equal 0, which it doesn't, so don't worry about that. And 4x does not equal 0, which means, of course, that x doesn't equal 0. In the denominator, we've got an x minus 2, x plus 2. So x does not equal 2 is the first one. X does not equal negative 2 is the second one. And then notice that's repeated there and there. You try these two. In the first case, 3x does not equal 0. 4x does not equal 0, which of course means x does not equal 0. And then 3 does not equal 0, which it doesn't, so don't worry about that. X does not equal 7. X does not equal negative 7. And then this factors into these two, so those are the different parts of the domain. X plus 19 does not equal 0, which means x does not equal negative 19. X minus 18 does not equal 0, which means x does not equal 18. So negative 19 and 18 are the two choices. Now, how do you go about solving them? Well, first of all, we found the domain. Then we multiply by the LCD to clear the fraction, solve the equation, and check your solution. Our LCD is 20x, so we multiply this by 20x, 20x, 20x. The 20s cancel in the first case, so we end up with negative 3x. The x's cancel in the second case, so we have 20 times 2, which is 40. And the x's and the 4 cancels against the 20 for a 5. 5 times 5 is 25. Subtract 40 from each side, and we get negative 3x is negative 15 divided by negative 3x equals 5. Now, can x be 5? Yes, it can here, because it can't be 0 there. So our answer is x equals 5. You try this one. Okay, common denominator is 12x. Multiply each part by 12x. The x's and the 3's cancel in the first part, leaving a 4. The 4x cancels against the 12x for a 3. 3 times 3 is 9. The 12 cancels against the 3 for a 4 on top. 4x. 4 minus 9 is negative 5, is 4x. So x is negative 5/4. Can't be 0 here, can't be 0 here. So this is our solution. Try this one. Multiply everything by x squared. We get x squared plus x equals 30. X squared plus x minus 30 equals 0. X minus 5, x plus 6 equals 0. So x is either positive 5, or negative 6. Next one. Multiply everything by x minus 1, x plus 1. All right, the x plus 1's cancel in the first case, so we have 3x minus 3. The x minus 1's cancel in the second case, so we're left with x plus 1. And then the x squared minus 1 cancels against the top, leaving that. So we have 3x minus 3 equals x minus, oops, come on now. That really went forward fast. X minus 1. Let's see, let's subtract x from each side, add 3 to each side. We get 2x, these cancel, equals, these cancel, 2, x equals 1. Now, 1 and 1 makes 2, so that's okay. 1 minus 1 is 0. So this, while this does solve the equation, it can't be the denominator, and so we say there is no solution. You try this one. Multiply everything by t minus 7, t plus 7. Okay, first one's the t minus 7's cancel, so you're left with the t plus 7. 2 times t minus 7 equals 14. This cancels. So, t plus 7 plus 2t minus 14 equals 14. Add 14 to both sides. Nope. Add 7 to both sides. You get 3t equals 21, so t equals 7. 7 minus 7 is 0, so 7 can't be one of our choices, so there is, once again, the null set. Another one with no solution. Well, actually it may have a solution, we'll see. Multiply everything by x times x minus 4. Okay, the first case, you're left with 3x. The second case, you're left with x minus 4. The last case equals negative 4. Add 4 to both sides. You get 4x equals 0. So x equals 0. And x can't be 0 right here, so we would say the answer is the null set. Okay, let's try this one. Now, you have to factor this denominator, x plus 3, x minus 2, x minus 2, x plus 2, x plus 3, x plus 2. So our common denominator is x plus 3, x minus 3, or x minus 2, x plus 2, x plus 3, x minus 2, x plus 2, x minus, or come on now, plus 3, x minus 2, x plus 2. Okay, this one cancels that, this one cancels that, so we're left with 4 times x plus 2. This one cancels, and you're left with minus 1 times x plus 3. And this one cancels, and this one cancels, so you're left with 2 times x minus 2. So 4x plus 8 minus x minus 3 equals 2x minus 4. 4x minus x is 3x plus, plus 5 equals 2x minus 4. Subtract 2x from both sides. Subtract 5 from both sides. You get x equals negative 9, which is fine because that's not one of the choices. X can't be 2, negative 2, or negative 3. So it can be negative 9. Okay, factor this first one. You get t minus 4, t plus 2, t plus 2, t plus 4, t minus 2, t plus 2. Okay, so multiply I'm going to change colors here. Multiply everything by t minus 4, t plus 2, t minus 2. T minus 4, t plus 2, t minus 2. T minus 4, t plus 2, t minus 2. Okay, this cancels, and so we're left at 2 times t minus 2. This cancels. Uh-oh. T plus 4 we need in there too. T minus 2, t plus 4. Okay, t plus 4, t plus 2, so we're left with 4 times t minus 4, t minus 2 equals, these two cancel, 2 times t minus 4, t plus 4. Okay, I'm going to change colors here. Multiply out the first ones, we get 2t squared plus 4t minus 16 minus 4t squared minus 24t plus 32 equals 2t squared minus 32. Okay, let's see here. Let's combine these two as negative 2t squared plus 4 plus another 24 is plus 28t minus 16 minus 32 more is minus 48 equals 2t squared minus 32. Let's subtract 2t squared from each side. And then let's add 32 to each side. Okay, I'm going to write it over here. Negative 4 squared plus 28t minus 16 equals 0. Divide everything by negative 4. And we get t squared minus 7t plus 4 equals 0. And that doesn't have any rational roots, unless I made a mistake someplace. You try this one. Oh, this factors into, let's see. Come on, how can that be doing that to me? We need a 3w minus 8w plus 14, 3w minus 8w plus 14. Assume those two are correct. Okay, this is missing here, so we're left with 3w minus 8. W plus 14 plus w plus 14 equals, these two cancel, and we're negative 3w and w makes 4w. Minus 8 plus 14 is plus 6. equals negative. Subtract 6 from each side. You get 4w equals negative 56. The w equals negative 14, which it can't be. Because of that, we would say our answer is the null set. Okay, this one. We've got a x plus 3, x minus 1, x plus 3, x minus 1, x plus 3, x minus 1. Okay, these two cancel, so we're left with 2 times x minus 1 minus, these cancel, x plus 3 equals, these cancel, negative x squared minus 3x. So add x squared to each side and add 3x to each side, and we get 0. X squared, this is 2x minus 2. 2x minus x is x, plus 3 more x is 4x. Negative 2 minus 3 more is minus 5, so that factors into x minus 1, x plus 5 equals 0. So x equals 1 or negative 5, but it can't be 1 because that makes this 0. So x equals negative 5. Next one. Hold it, that's the exact same problem. Try this one. Multiply by x times x minus 2, x times x minus 2, x times x minus 2. Okay, the x minus 2's cancel. The x's cancel. The x minus 2's cancel. So we're left with 2x squared equals negative 3 times x minus 2 plus 4x. 2x squared, this is negative 3x plus 6. So 3x and 4x is 7x. So we're going to subtract 7x from each side. And then subtract 6 from each side. So these cancel. Hold it. Nope, 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 nope. Negative 3 times, this is a negative 3x plus 4x is just x. So subtract x from each side. Subtract 6 from each side equals 0. What two numbers multiplied equal 12 are 1 apart? Negative 12. It would be 2 squared minus 4x plus 3x minus 6 equals 0. So we get 2x parentheses x minus 2 plus 3 parentheses x minus 2 equals 0. 2x plus 3 times x minus 2 equals 0. So 2x plus 3 equals 0, which means x equals negative 3 halves. X equals 2, which is okay. Nope, not okay. 2 minus 2 is 0. So that one works. So x equals negative 3 halves. Okay, graphs of functions. A function defined by a quotient of polynomials is a rational function. Because one or more of the values are excluded, it is a discontinuous. There will be breaks in the graph. One simple rational function is graphed on the next slide. The domain of this function includes all real numbers except x equals 0. These are called asymptotes where x cannot equal 0. By the way, y can't equal 0 either, and so that would be the horizontal asymptote. So you see, we've got a vertical asymptote, and we've got a horizontal asymptote here also. In general, if the y values of a rational function approach infinity or negative infinity as the x approaches a real number, the vertical line x equals a is a vertical asymptote. Also, if the x values approach a real number b as the absolute value of x increases without bounds, the horizontal line y equals b is the horizontal asymptote of the graph. We're looking for we're looking for x to get really big or really small, and we're looking for y to get really big or really small. Let's look at this one here. The first thing, I thought there was a table of values to fill in. There isn't. We'll have to make our own table of values. Okay, the first thing that you'll notice is x equals negative 3 is going to be a vertical asymptote. Okay. Now, y can't equal 0 because it can get close to 0, but it can't equal 0 because the denominator is a whole number. Okay, so we're going to have a horizontal asymptote also here at y equals 0. So basically, the only thing we have to figure out is our graph going to be like this? And like this and this, or like this and this? Because you always switch sides after the asymptote. Probably the easiest thing to do would just see what happens here at negative 4. So if x equals negative 4, 2 over negative 4 plus 3, negative 4 plus 3 is negative 1. 2 over negative 1 is negative 2. So you can see what's happening is we're down here, and so our graph is going to go like this. Graph is going to go like this. Let's just prove it by choosing the point x equals 0. So it'll be 2 over 3, which if you notice, that's about where I graphed it. So it's really easy once you get the vertical and horizontal asymptotes to figure out what's going on. Let's try this one. Notice x is not equal negative 1, so we've got a vertical asymptote here at negative 1, and since y has the numerator, it can't be 0. So probably the easiest thing to do is graph what happens when x is negative 2. Well, if x is negative 2, it's 1 over negative 2 plus 1 is 1 right here. And the graph is going to go like this, which means our graph is also going to go like this. So if we try x equals 0, 1 over 0 plus 1 is 1. And if you notice, that's where we went through. Okay, you try this one. Notice our vertical asymptote is 0. Horizontal asymptote is also 0 because if you notice the numerator can't be 0. Let's try negative 1. 4 over negative 1 is negative 4. So back 1, down 4 is one of the points. So our, oops, we didn't quite turn the corner quick enough there, did we? And same thing we drew over here. So I'm guessing positive 4 will be positive 1. Okay, another one. X equals 4 is a vertical asymptote. X does not equal 4. And the numerator is a whole number, so y must be the other asymptote, the horizontal asymptote. Let's try the point 3. If x is 3, 1 over 3 minus 4 is negative 1. We're going to be down here. And so this will also be 5. If x is 5, 5 minus 1, 5 minus 4 is positive 1. We could try 0. If x is 0, 0 minus 4 is negative 1/4, which I didn't quite get there. I should have